Ploker, Water Reuse Project Manager with Rainwater Management Solutions. Right now, we're going to discuss a commercial standalone UV light. This would be used in conjunction with other filtration equipment. On our commercial rainwater treatment skids, you would typically have a self-cleaning filter, a 5-micron bag filter, a activated carbon cartridge filter, followed by this UV light. Again, the entire purpose is to get the water as crystal clear as possible before running it through the UV light. Adequate filtration prior to the UV light increases the efficacy of UV sterilization. This happens to be a Viqua H+ unit. In our treatment services, we would use this for a skid up to 35 gallons per minute. If you have water that is filtered down to 5 micron and you can get the UV transmittance, meaning how much UV is getting through the water, upwards of 90% transmittance, then you can achieve what is known as 40 millijoules per centimeter squared. It's a measuring system used for UV intensity. At 35 GPM, if you can get 40 millijoules out of that, then you're really sterilizing the water. That is a very high cleansing rate. So this unit is powerful enough, it doesn't draw too much power, but it's powerful enough to have a fan to keep itself cool. UV light's going to be a bit warm. On its controller, it does have indicator lights, which will show you if there's a fault with the bulb or if the bulb needs changing, if there's a fault with the controller itself, or if there's a fault with the UV intensity indicator. One of the benefits of this particular model, which makes it a commercial unit, is that it does have a UV intensity sensor. So we're just going to be monitoring how much UV is coming through the water. And if there is a dip below its set point, it will give you a fault on the controller. That sensor will plug in midway through the chamber. Inside the chamber, you will have the UV bulb itself. It's important that it stay crystal clear so that it does achieve optimal transmittance. It will slide inside. These tabs will ensure that it is more or less in the middle of the chamber, floating, and not all the way against one side. Of course, there are O-rings, just like with most plumbing applications, you have O-rings for a tight seal. When you look inside the stainless steel chamber, you will see an almost mirrored surface. That way, the water is getting UV transmittance through it, and then it's getting reflected back. You want all of that water to be exposed to the UV sterilization. In terms of filtering, before you get to your UV sterilizer, it's important to get that water as crystal clear as possible, as I indicated earlier, because if you have a piece of sediment, say it's larger than 5 micron coming through the chamber, and there is bacteria, which is orders of magnitude smaller than most pieces of sediment, and it is basically behind that piece of sediment, the UV light is going to be hitting the sediment, and the bacteria will remain in the shadow, so it will not be deactivated by the UV light. UV sterilization will work to disable the pathogen rather than kill it outright. We don't use as much power or radiation in these lights that will fry and kill a bacteria or a virus. We're just looking to disable it so that it cannot reproduce. And again, getting your water as crystal clear as possible before the UV will enable more of any potential bacteria or virus to be disabled. Again, these will mount on our commercial skids. They use standard 120 volt power. They also have an informational cable so that the info from the UV light itself will be relayed to our controllers. And we can read its history, we can see in real time its performance, and also relay that information to building automated systems. RMS does a lot to integrate all of our filtration and sterilization within a controller that is able to talk with a building automated system. But with adequate UV sterilization, your water will be safe without the use of chemicals.